Hey, 7th grade teachers, Jeremy Blinn here, your friendly neighborhood science curriculum specialist. And I wanted to go over some information about the DIA3, 7th grade DIA3 context-dependent item sets that's coming up. I want to help you get prepared to help prepare your students for this type of questioning. If you're not familiar with this, and the training probably has already gone over this, but just to make sure that you realize that there'll be multiple questions referring to the same data sets. They could be pictures, images, data sets, graphs, and that's the idea behind context-dependent sets. They are what is also asked on our state assessment, and so this is just practice. Anyway, so last year when we threw these on the DIAs, many of you were giving us feedback as to how do we help our students prepare for these without actually teaching to the actual test, the test questions specifically. So the quickest answer to that is simply teach the scientific phenomenon. What is the scientific phenomenon that is actually the whole reason why we have learned all of this about science? But let's dive into this one in particular, this whole particular test. The benchmarks are listed below on this chart, or on this slide. You can see I have bolded the areas of which part of the benchmark is really addressed during the CD set in this particular assessment. And without divulging any specifics of it, but if you saw it last year, you know there's a certain particular island in the Pacific island chain that this is regards to. The key thing would to not be teaching any island formation in isolation, any particular island chain, but the phenomenon of island formation due to hotspots like volcanic growth from the seafloor up. So if you teach how that concept happens, and you could do it by demonstrations, you could do it by a multitude of ways to help your students kind of experience it. But what we found is when we utilize any of the science practices, that's those 8 science practices, and we give the students the opportunity to do one or more of those, then they experience the phenomenon themselves in a particular way. So the one we're going to focus on in this is models. We're going to have our students using and developing their own models. This approach is going to be actually the students developing something called the student initial thinking model. So let's look at this. The 2 scientific phenomena that are really addressed in this particular item set is the formation of islands over underwater magma chambers, hotspots, over time. And the other one is the lithosphere movement due to plate tectonics. So how do we get our students to discover this and develop their own models in this? Well, here's the key thing. I'm not sure when you're watching this video. In fact, you may have already started teaching about plate tectonics. If that's the case, this still could be used because you could use it to engage formatively how much do they know so far. So when I show you these models, think of it as, well, I've already taught them some of this. Let's see how much they know. But this is best used as an initial engagement and process of students getting students thinking and seeing what they know, seeing what they don't know, seeing what misconceptions they bring to it, and even expose them to describing what they're seeing and see how complex or limited their vocabulary can be. Anyway, let's dive into this. So the first thing I'm going to do is show you a video that you may start off with because it'll help engage the students. Now, I'm going to not be able to talk over the video because there's some sound, but you may use this video, for instance, something like this, and stay quiet, and then stop the video after about 10 or 15 seconds, so there's no narration. You may ask them, what did you just see? Something like that, and brainstorm, get the discussion going, see what the kids know already about underwater volcanoes and island formation. Or let it keep going. After about 15-20 seconds, a narrator comes out and then says just enough to lay a foundation for some of the students you think may have zero background in this. This could help them out. Anyways, let's check out this video. Click forward.
While the surface of the ocean is still 2 miles up, the volcano spews out enough lava to create a first platform. This becomes the foundation of an undersea mountain.
And scene. All right. So like I said, you could just play the first 15 seconds where there's just the sounds and no narration, and then ask your students, what are you looking at? What do you see here? Some of them may come into this knowing a little bit about underwater volcanoes, but will they lead it into not just underwater volcanoes, but the potential new land development? Is this something that they'll connect to that could become an underwater mountain to then eventually break the surface one day and and be something we can see as an island? I don't know, but the narrator gives us the foundation of a future island. So that's something that we could use if you want. Now, where we go with this, let me explain. This is the lead up to first giving them some background and stimulate something of prior knowledge. Then when we go to the next screen, you show them this on a PowerPoint. If you could broadcast this so on a whiteboard or something so that you could fill out things that they're telling you on here, it would be great. And you have your camera for your Volusia Live. This could be done on a Nearpod, on a Draw It feature. But right here is where you want to initiate discussion and get the kids to fill out what they see. So this is an image. We'll call it image 1. Good name, right? And have them label what they see. So kids, tell me, what do you see? What do you see? Well, they see a volcano. Okay, well, they see a volcano. They see some smoke. They may be labeling, well, label everything. The sky. Label the sky. You want to get everything out from the kids. The reason why is you just want to pull out what do they know? What don't they know? Are they going to call all parts of this lava? Do they know what magma is? Do they know what a magma chamber is? Do they know a magma reservoir? Again, all those details aren't necessarily important for the DIA, but it's just getting we're stimulating their prior knowledge because we're going to get to really those two phenomena, island formation and plate tectonics, movement of the lithosphere. So pull out as much information as you can from them. And have the students label everything they can. Maybe they give you enough information to label all this. Key thing here is you do need them to see there's water. That this is an island. And this little thin blue line represents water, the ocean, and that may be a little difficult for them to notice, but you definitely want them to see that so we can start talking about if this volcano is surrounded by water, then what is it called? What is that landform called? An island. They may not have the term lithosphere yet in their vocabulary. They may just call it the ground. They may see all orange areas that end up shooting out of a volcano as lava. They don't know any other definitions. So be willing to just accept anything they say at this point and write it down. So that is just a labeled image. This is not a model. Let's talk about that. What is a model? Just like it says below, I'm going to read it. It says these are just representations that the students we were asked to identify these parts of this system. So we definitely have a system going on here, whether they know it or not. It's not a model unless it also depicts the relationships between these parts. And then they can be used to ask questions. The students ask questions about it, or they explain or make predictions. So that's when this will become a model. Well, how do we stimulate the kids into creating a model? So we now have talking parts. Like if they were to label a future model, they could call that a smoke and volcano and lava. They can call this the ocean, the sky, the ground. And we want their initial model to be purely just what they call things, because it should change over time. Tell them you're now going to see a second image and pay very close attention between the difference between image 1 and image 2. What's the difference? Ask your students. Well, the obvious is, now there's 2 volcanoes. They should pull out and observe that one of them's got smoke. Be specific. Which one? Number 2, volcano 2 has smoke and it's got that lava going down into the orange area. Oh, but volcano 1, did they notice that was called volcano 1 too? There was a 1 under that volcano. Now, there's volcano 1. What else gives us some indication of change? 1 million years later. So this is a change over time. Pull as much as you can from the students out of the differences between image 1 and image 2, and then tell them we're going to see an image 3. Watch closely and be able to explain to me what you see as a difference. Image 3. What's different, students? take all their accept all answers that seem logical. And what do we see again? We see a volcano 1. We see a volcano 2, but now there's a volcano 3. And a duration of time has passed, 1 million years. So have them they're going to start making some inferences potentially, but they may be incorrect. So this is what we want to capture. Tell them, you've seen now image 1, image 2, and image 3, and each one of them has changed a little bit. Ask them, what do you think a 4th image would look like? Oh wait, don't yell out loud. I want you to put it down on your paper. So hand them the handout that we've provided you that has this. What would the next image look like? Label your model to explain what is happening. What are some of the limitations of this model too? So you have this blank area to hopefully list 4 volcanoes. We didn't bring it up, but did you notice that volcano 1, 2, and 3 are different sizes? Volcano 1 is significantly shorter than volcano 2. Now, they will not have gone over weathering and erosion yet. That's the next unit. But this model, this phenomenon, you could keep using into the next unit when we get into rock cycle. Or they could imply and infer right now that, well, if that island 1 is now 1 million, 2 million years later, they may even get to the logical thinking of it's being eroded away by wind and water. Maybe not, but you can definitely bring that back up next unit. So what would the image look like? You want them to make the drawings and do detailed drawings and explanations. What are we looking for? Well, this is an initial student model. Not sure what the expectations are, but not one of the previous images included an arrow showing movement of the Earth, what we know as plate tectonics, the lithosphere moving. They may not get that. They may, in fact, think the lava is moving and popping up and creating islands. That's a very common misconception when you go from one of these images to another. But what you want to challenge them to do is make a model. Thus far, there has not been a model. The model would be all the labeling and then explanation. And this is a prediction in itself, so it's starting to become a model. Anyway, this is called the student initial thinking model. Now, your classroom may not be conducive, especially in the modalities, where students can partner up and share their models to get together to make modification to their own model. But that's technically a good step to do in this process. But you may want to definitely get a group share out and get a consensus model displayed in your classroom. Now, remember, that's the student initial thinking model. Put the misconceptions up there. It might hurt to go, no, that's not what's happening. The lava is not moving. But put it up there, because when you start explicitly teaching about plate tectonics, reading, and going through the things and the demonstrations you may potentially do, this model should change. You should have them revise their student thinking model. That could be another page in their notebook. What should the model look like now that you've learned this? Anyway, all of this could lead into something called a student question board. That's a different training on another day. But for instance, after the students made their initial thinking model, they may have these types of questions. Now, why are the volcanoes 1, 2, and 3 becoming smaller? Are the volcanoes moving? Is the lava moving under the water to build volcanoes? Is volcano 3 still growing? I mean, it has one of those, it looks like a lava straw or tube. They're not going to have the vocabulary, but these driving question board, this is student questions. If you solicit questions they have after they've built this model, you now have a bunch of questions that they've asked that they want to find out, and you will provide them the content. Sorry, the microphone, the content and the information for the next several days. Anyway, I hope this has helped. Give you an idea. The idea behind this modeling is to get the students to do it. Don't throw everything at them, make them think. And this is just one potential way. We'll go over other ideas as we go through other DIAs. But I hope this whole training has been a benefit to you. And I know that you have either had a long day and you've attended this training, or you're just about to have students come in your classroom. So have a great day nonetheless, or a great evening. And thanks for watching.